Hi, today I'd like to show you a difference between line coverage and mutation coverage based on a very small Ruby example. The example is taken from the exercism.io, it's the exercise called hamming. I've used this example to artificially show some DDD concepts in the previous videos, but now I want to take this code and check what is the coverage and explain what's the difference between the line coverage and mutation coverage. Overall, the coverage seems to be pretty good and all the tests are running. So now I will run the tests with line coverage. I'm using the RubyMine built-in feature with the coverage and is using simple conf. And as a result, it showed me that it's 100% lines covered, the hamming file. Hamming test, I don't care, I'm not really testing the test, I'm testing just the part here. Also, RubyMine shows me this green bar here. If some line wouldn't be covered, like whatever here, and I run this again with coverage. This is showing me this red part here, and also it's saying that it's now 96% coverage because of this line wasn't really executed. Fair enough, because we never called the foo method. Alright, but without this method we have 100% of coverage. Let's make sure again, 100%. It's all good. Now I will use Mutant. Mutant is the Ruby mutation testing library. One thing here, Mutant in its stable release doesn't have the minitest support. You need to install Mutant with the minitest integration branch. But once you have it installed, you just call this, run the mutation testing here, and bam, we have a red color. And that's interesting. Those lines show me what kind of mutation was applied. So in here, basically, what previously was wrapping the DNA1 with a strand object, apparently I can just use the DNA1 everywhere else and all the tests are still passing. At first it was hard to believe for me, so I checked it again manually, ran the tests, and they are passing. Damn. Apparently the same happens if I replace the second one with DNA2. It's green. Alright, so something interesting is going on. What happens if I use both of them? Does it mean that I don't need a strand object in order to have the tests pass? When both of them are changed, we have some tests failing. The problem is that the only test I have for the validation of the input is one test which is using both codes which are incorrect. And for the tests to pass, it's enough if just one of them raises an error, because we will end up here and we will raise an argument error. So it doesn't matter what happens with the second one. Now, is this a big problem that I'm lacking some coverage here? When you look at it, like, why would ever anyone change this but wouldn't change this? Yeah, it shouldn't happen. It's probably not really very statistically important here. But I've seen many situations when people refactor and make not so small steps, and somehow like some refactoring that can be applied here. I can imagine that this would be wrapped with a command object, or that we pass those DNA into service object and the service object itself is responsible for wrapping this into strand or not. Again, it's not very likely, but I can imagine that in those kind of situations when you pass the objects around across some layers, you can forget, or you can change, you can switch to just using DNA one in one place. Can happen. So it doesn't really hurt me to add new tests, and that's what I'm going to do. So I actually want to have two tests, and disallow incorrect code 1 as the first argument, but I want to say that this is correct, and now I want to say that this is the correct one and this is incorrect. Tests are passing here. The coverage, the line coverage should still be 100%. Yes. And mutation, 100%. So that's much better, and I feel a bit safer. So mutant is not only showing me the coverage here, but it's also helping me with making sure that I did the right thing. So when I wrote this test, the first one, I was really sure that that's enough, and that's also the temptation of a typical developer like me, just to have one assertions, put both arguments which were wrong, and that's enough. I covered it, but it wasn't really covered enough. And that's the main difference here. Mutant showed me the difference, while SimpleCov or any other line coverage tool wouldn't show me the difference. And that's why I prefer to rely on Mutant, and that's why I think it's worth starting to use Mutant, because it's stable enough for now. Thanks for watching. Don't forget to subscribe to the Arkansas YouTube channel. See you later.